is Mr. Agbamu Danogrene. In today's class, I want to show us how we can differentiate a function of a function. And that is going to be my objective of this class, how to differentiate function of a function using basic rule of differentiation. So in our last video, I explained how you can differentiate basic polynomial using our basic rule of differentiation. You saw how we did different differentiation, different functions, fractions, and the rest using our basic rule of differentiation. So if you go through that video very well, so function of a function is not going to be a problem for you, just for you to listen and pay attention. So if you remember in our last video, this was what I did. I did something of this kind. Let's say you have a 3x raised to power, let's say raised to power 2. This was the kind of expression we differentiated. So the kind of function we differentiated that we call polynomial functions. And the basic rule says the power 2 is going to multiply the coefficient of this x, which is 3. So this is going to give us dy dx, which is 6x. Then the power 2, we are going to subtract 1 from it. So our answer here is going to be 6x when you differentiate this function. So now, assuming you have a situation like this, 3x squared, this is a function. So assuming you have a situation like this now, let's remove this 3 out of here. You have something like this. This x now, let's say, okay, let's open bracket now. Okay, you now have the 3 inside, 3x raised to power 2 is inside the bracket, and let's say plus 5, then raised to power 2. So this is an example of a function of a function, because 3x squared plus 5 is a function. Then this bracket alone raised to power 2 is another function. So 3x squared plus 5 is a function, then bracket raised to power 2 is also another function. So when you are asked to differentiate a situation like this, instead of you expanding this bracket first, then using our basic rule to differentiate, why not use the rule called function of a function to solve this kind of question, instead of you opening the bracket first? Though this case is a simple one, I can open this bracket and differentiate this one. Since it's power 2, it will not take me time. But what if this power is increased? Let's assume this power is increased to something like, let's say it's increased to something like power 12 now. And you know, in your binomial theorem, if you want to expand this to power 12, you know your expansion is going to be very long, and before you finish expanding it and start the differentiation, you know there's no time. So why not learn your function of a function and get how to do it? And to differentiate this fast using our basic expansion, you know what I'm going to do? If I expand this bracket, what I'm going to get 9. If you do the expansion fast, 9, that is 3 square x square, which is 9x raised to power 4. That's what you have in this place. Then plus 2 times 3 will give us 6. 6 times 5 will give us 30. So you just multiply 2 times 3 times 5, which is 30. Then x square will be attached there, x square. Then finally, when you square 5, it's going to give you 25. So if I now differentiate this with our basic rule, dy dx, you see, if we differentiate this function now using our basic rule, we would now get 9x raised to power 4. When you differentiate this function, it's going to give us 9 times 4, which is 36x raised to power, then 4 minus 1, which is 3. So you are through with that. The next term is this, 2 times 30, you're going to get your 60, then x, then 2 minus 1 is 1, so x, 60x. Then 25 is a constant. The precision of a constant is 0. So this is your answer when you differentiate this function. Let me put it in this corner so that we'll explain function of a function in this side. So you can see the answer we got. So mere looking at this, some people may say, why not expand and differentiate? Why wasting time? using another rule called function of a function. You will appreciate function of a function when you have a greater power here. If this power is to be 20 and they tell you to differentiate, before you can expound this bracket to power 20, so time will must have gone. Then before you start the differentiation, there's no time. You start differentiating each term. You are going to have so many terms. So to avoid that, you use function of a function. So if I want to differentiate this using function of a function, let me write the question out again, which is 3x raised to power 2 plus 5 all raised to power 2. Alright, so this is the question. So what function of a function says we should do is this. Since what is inside the bracket is a function, then the bracket itself raised to power 2 is another function. Then take a value. Say you can use value u, any variable you like. So let u, some people can use t, so just use any variable. So let me use u. Let u equals to what is inside this bracket, which is 3x squared plus 5. So you are the one that created this. If you want to use function of a function, the first step is to make what is inside the bracket to be equals to u. Then now that we have done this, then let's differentiate u with respect to x. So if I differentiate u with respect to x, which is du dx, like this one, du dx is going to be equals to, basic rule says 2 times 3 is 6. Then subtract 1 from 2, which is x, minus, which is 1. So this is 6x. Constant 5 is 0, so you ignore that. So when you differentiate u with respect to x, this is what you are going to get, 6x. So you are through with this. Then since you allow u to be equals to 3x squared plus 5, so u is equals to this function, then the full function now is y is equals to u raised to power 2. You know, u is being replaced with what is inside the bracket. Then the bracket raised to power 2 is this. So that is this now. Then if I also differentiate y with respect to u, I'm going to have dy du. Remember what I told you in our last video on differentiation of polynomial. I said they can ask you to differentiate any function with different variable. It's not always x and y we use in differentiation. You can use any variable. You can say now we are using dy du, we are using du dx. Just follow the rules of differentiation, that is all. Know the variable that is outside bracket, know the one that is inside, that is all. So dy du is going to be 2u, following basic rules of differentiation. Now this is where the function of a function rule comes in now. If you look at what we differentiated now, dy du dx, if you multiply these two, let's multiply these two, you will see what we are going to get. If I say dy du times du dx is equals to, I want us to see it well, we said dy du, which is this, times du dx will be equals to what? Mere looking at it, you can see du will cancel du. So when du cancel du, what is going to be your answer? Your answer is going to be dy dx. You can see it. You understand what I just did? Du will cancel out this du, leaving dy times 1 dy, du times, dx times 1 dx. So what I'm indirectly trying to say is dy dx is equals to dy du times du dx. So this is the basic rule we use when we are differentiating with function of a function. So let me put it in box so that you take note of it. This is very, very important in function of a function. And with this principle now, we call this one, in differentiation, we call it the chain rule. So it's called the chain rule of differentiation. So this is the chain rule of differentiation. So take note of this. Is very, very important. So most people use this method in solving function of a function. So this is the chain rule of differentiation. So if you are using this, what are we going to do now? Final answer. So to end this solution now, you see we are going to get the same answer we got here when we expand this bracket. So to our final answer is now going to be dy dx will now be equals to, so we said dy du, which is 2u, so you have 2u, it's going to multiply du dx, which is du dx, which is 6x. So that is that. Then if you now do if you now put your value of u now, or before we do that, let's use 2 to multiply 6. 2 times 6 is going to give us what? That is 12. Okay, let's put dy dx will now be equal to 12, like 12ux. Okay, or let's say 12x. Let me put it like that, 12x. Then open bracket, note 6x times 2 is 12x. 12s u, then u, now let me put it in bracket. Since u is this, I need to substitute the value of u, which is 3x raised to the power 2 plus 5. So that is the value of u. I need to replace u with its correct value. Then if you open the bracket, you will see that you are going to get the same answer. I'm going to get the same answer we got in this place, which is dy dx. Y dx is equals to 12 times 3 is going to give us 36. Then x times x squared is going to give us s cubed, which is the first term we got here, you can see. Then plus 12 times 5 is going to give us 60. Then x times 5, which is 60x. So this is the answer of the differentiation of this. So this is what we do in function of a function. Take note of that, and that is all about function of a function. Function of a function is very important in differentiation. When you want to differentiate square root of a number, we use function of a function. Most especially square root that have 2 terms in them, a binomial root like 3x squared plus 5, square root of 3x squared plus 5. We use function of a function to do such differentiation. I'm still going to do that differentiation for you to get very well. So let me remove this, that will get it. Let me close this. Okay, so but if you don't want to use this method, most times I don't like using chain rule when I want to solve function of a function. Let's put this, or you can use this other approach. Most times this other approach I like using most times. So if I have this same question, which is y equals to, let me open bracket, 3x raised to the power 2 plus 5 raised to the power 2. So most times I don't like using this chain rule to solve my function of a function. What I usually do is this. Since we all know the basic rules of differentiation, and what is the basic rule? We say when you have a number raised to a power, let me put the basic rule here so that we'll get what we are saying. Let's say x raised to power, let's say raised to power n. Remember what we said? We say our final answer dy dx is equals to n, which is the power. We say this power. We say this power n is going to multiply this coefficient in front of the x, which is nx. Then the power we are going to subtract 1 from it, which is n minus 1. So this is the basic rule. Since we all know this basic rule, why not use the same thing here? This 3x squared plus 5 is a function. It's also raised to power 2, which is another function. That is why we call it function of a function. Then if x raised to power n is a function, and to differentiate a single function we use n times coefficient of l, which is nx, then which is now raised to power n minus 1. Since this is what we do, why not do the same thing here? Why not just go straight to the point? Dy dx is equal to, I'm gonna just go straight like this. The y dx is equals to, keep this bracket, don't touch this bracket, but follow the basic rule. What is the power here? The power is 2. So you put it down 2 times, what is the value in front of the bracket here? It's 1. So 2 times 1 is 2. Then open your bracket, write everything inside the bracket the same way, raised to power 2 plus 5. Then the power 2 now minus 1. So 2 minus 1 is 1. So it will now be power 1. So you leave that one like that. Then we are now here now, but don't stop here. Don't stop here. The next thing is multiply. Then you introduce d dx. D dx is another form of writing differentiation. So d dx of what? So when you write d dx, then you open your bracket, repeat everything inside this bracket, write it inside this bracket. After d dx, you write 3x squared plus 5. Don't forget it inside this bracket, which is 3x squared plus 5. So that is what we have inside this bracket. Okay, so by the time you repeat it out like this, the next thing is this d dx shows that you need to differentiate what you have here. Then whatever answer you get here, times it with this other bracket, and that is all. You will get the same result that we have here. So with this, you go fast, you say dy dx is equals to same thing 2. Now this 2 can open this bracket. Since the power is 1, you can use 2 to open this bracket, which is 6x raised to power 2 plus, then 2 times 5 is going to give us 10. So don't forget, let's put it in brackets. Sorry, let's put it in bracket. Okay, I need to supposed to have started with the bracket from the beginning. Let me cancel this. Okay, you open your bracket, which is 6x raised to power 2 plus 10. Okay, so I just open this bracket. Remember, I'm still going to multiply another number here, so that is why I left it like that. So we have times, then let's differentiate this. That is the meaning of d dx. You differentiate this, what is inside the bracket. So when you differentiate this, you are going to have 6x plus 5 is a constant, which is 0, so you are going to have 6x. Then that is that. Now final answer, you see we are going to get this. What are you going to do now? Open this bracket with your 6x. So 6x times 6x squared, you will get the y dx. The y dx is 6 times 6 will give us 36. X times x squared will give us x raised to power 3 x cubed plus 6 times 10, you get your 60, then 60x. You can see that we got the same result. So that is that. So why I prefer this method, in a way you can see that this method is very fast. Just differentiate the function as if it's a single function, bring the 2 down, leave this function, don't touch it, raise to power, subtract 1, you get this, times d dx of whatever you have inside the bracket, that is all. The next step, differentiate whatever you have in this bracket, times it with the other result you have here, which is this, and that is all. So this is all about function of a function. It can never be difficult than this. Just take note of that. So before we go for today, let's try another example. I want us to see something like this. Let's try something with square root. Let's assume you have a question with a root. Let's say you have to solve something like this. Let's say y is equals to square root. Y is equals to square root 3x squared, 3x raised to power 3, let's say minus 7. It means you are asked to differentiate something like this. I can just ask you to differentiate. I can ask you to differentiate this. You can just say differentiate this function. ask you to differentiate this. How do you do that? Remember, it's also a function of a function problem. So you are going to use the same chain rule or use the other approach that I explained. So I will still use both methods so that you understand it very well. So to start, the first thing you need to do in this case is put your y in the index form, which is remove the square root, it will turn to 3x cubed minus 7 raised to power half. Hope you still remember from our basic rule I did something like the square root is also the same thing as raised to power half. So you do this first. Then the next thing to do now, if you are using your chain rule says let u equals to whatever you have in the bracket, which is 3x cubed minus 7, that is all. Then you differentiate du dx. You differentiate u with respect to x, you are going to get 3 times 3, which is 9. The basic rule, don't forget. 9x, then 3 minus 1, 2. Sorry, x raised to power 2. That is that. Then the next thing is your y. You need to substitute u into this expression here. You're now going to have y is equals to u raised to power 1 over 2. Then you are going to differentiate this also, which is dy du. So dy du is now going to be equals to, so which is 1 over 2. The power is going to multiply the coefficient, which is 1 over 2 u raised to power what? Raised to power half minus 1, which is minus half. So raised to power minus 1 over 2. So that is that. So by the time you get this, you see there's no issue and no problem. Then the next thing is to get your final answer, dy dx. So dy dx is now equals to, we said dy dx will be equals to what? It's going to be dy du, which is this value you have here, 1 over 2 u raised to power minus 1 over 2. Then that is that. Then it's going to multiply times du dx, which is 9x raised to power 2. So that is that. Then to finalize your answer, you need to put this in the right order now. Let's put it in the right order, which is dy dx. So dy dx will now be equals to 1 over 2. Then you know this is negative power, so when you have negative, now it will now be 1 over u. So u is going to be in denominator raised to power half. So u raised to power 1 over 2. Then multiply by, going to multiply by 9 times 9x squared. So that is that. Then let's finalize our answer here. Then your final answer, if you want to finalize it now, you need to put the value of u. dy dx will be equals to, if you substitute the value of u into this place, which is 3x raised to power 3 minus 7, you are going to have 1 all over 2. Okay, let's put the root first. 1 all over 2. The 2 is going to be in front of the root. Okay. 2 roots 3x raised to power 3 minus 7. So that is the value of the u here. Now I've substituted the value of u now, and half is the same thing as square root of u. So that's what I just did. Then times, so 9 is going to be in numerator, so not 1. So 9 times 1 is going to be 9x raised to power 2. So this is your final answer. You can see it when you differentiate this function, square root of 3x cubed minus 7. So this is the answer you are going to get. So you can see why I said I don't really like using this chain rule method. See, it's somehow long. If I'm going to use if I'm going to use this method, you see that our answer will come out clean and neat. So when I have my y is equals to, open your bracket, 3x raised to power 3 minus 7. So this is the second method I said I prefer using. Then raised to power, now have raised to power 1 over 2. So you can even see why it's even good to know function of a function. If you want to expand this bracket now, raised to power half, how are you going to expand it? So to expand this is very difficult, to expand something like this. So to avoid all those stress, why not just use your square root? Use your function of a function rule. So according to function of a function with this method, what I'm going to do is direct to my answer, the y dx is equals to, so I'm going to differentiate this as a single function, which is 1 over 2 is the power, is going to come here, 1 over 2 is going to multiply the number in front of this bracket. So you open your bracket, leave everything inside bracket, don't touch it, raised to power 3. Then the next thing is half minus 1, which is raised to power minus 1 over 2. So that's that. Then the next thing you do is d dx. Don't forget, we say you are going to multiply by, you're going to times with d dx. So d dx of whatever you have in the bracket now, you open your bracket, what do you have in the bracket, which is 3x cubed minus 7. Then in your next step, you are going to differentiate this. Whatever you have here, use it to times this, and that is all. So dy dx will now be equals to, then this is 1 over 2, then this is raised to power minus, it will now come down as open bracket 3x raised to power 3 minus 7 raised to power 1 over 2. So this negative we remove, we leave this place, it will now come down as 1 all over. So that's what happened to this place. Then you move on, then times, then when you differentiate this bracket, that's the meaning of DDS, to give you 3 times 3, which is 9x squared. That is 9x squared. So you can see we are getting close to this step of this other method. Then final answer we are going to get now, the y dx is now going to be equals to, so 9 times 1, this is going to give us 9x squared divided by 2, okay, divided by square root. You know, half, the number raised to power half is square root, divided by square root. Don't forget your 2 is going to be here, divided by 2 root 3x raised to power 3 minus 7. So that is all this method. If you compare, you can see we got the same answer. So this is all about function of a function. Whenever you meet a question that have 2 terms or 3 terms, but the most important thing is you have something in bracket raised to a power like this, it's an example of function of a function. You have a question with root like this, we have 2 terms inside the root, you use function of a function to solve this kind of question. If you look at the first example we used to explain it, this type, you can see them, anything in bracket 2 terms, it can be 3, 4 terms, as long as this bracket is having another power. So that is function. What you have in the bracket is a function, then the power is also another function. So this is function of a function. It can never be difficult than this. And that is the end of this class. I hope you understand all we did today. So just take your time and go through the video, then you can practice these 3 questions for assignment. So do hope you enjoyed the video and do have a nice day. Take care.